In this video, we're going to continue to solve inequalities and graph solutions. So let's look at our next problem. We have the product of 3 and the difference of x minus 5 is less than 12. So let's write out our construction process. X is decreased by 5. Now the decreasing is a difference, so the difference is multiplied by 3. And the result is less than 12. And now let's just put some notes on the side. So we have x is decreased by 5, the difference is multiplied by 3, and the result is less than 12. So now let's deconstruct this. We're going to start with 12. 12, instead of multiplied by 3, is divided by 3. 12 is divided by 3. Then that's a quotient. So the quotient is now increased by 5. And now this is where we're going to be careful because we have inequalities now. We're going to say x is, so always start with x. We didn't multiply or divide by a negative, so we're going to keep the less than. X is less than the result. Okay, now let's write this out. Okay. So I'm going to start a little bit to the right because I know I'm going to have to put x on the left-hand side at the end. So 12 is divided by 3. The quotient is increased by 5. And x is less than the result. Okay. Now if we compute this, we have x is less than, this is 4. 4 plus 5 is 9. Okay. Now here, let's see how we would write this using the properties of inequality. So we have 3 times x minus 5 is less than 12. First, we're going to divide both sides by 3. So divide this whole side by 3 and this whole side by 3. On the left-hand side, since this is a product, okay, the 3's cancel to 1. Okay, because 3 divided by 3 is 1. It doesn't cancel to 0. Now we have x minus 5. So I'm dropping the parentheses because all I have now is the difference, is less than 12 divided by 3, which is 4. Okay, so I divided both sides by a number. Now I'm going to add 5 to both sides of the inequality. And my result is x plus 0, so negative 5 plus 5 is 0, is less than 9. And that corresponds to our previous result. Now let's graph this. So first our boundary value is 9. So I know 9 is right here. There's no line underneath, so it's a strict inequality, so I'm going to use an open circle. Okay, and again, now I have to decide, is it the numbers to the left or the numbers to the right? Okay, now this says x is less than 9, and these are the numbers less than 9. But again, as you're still learning this, you might want to pick a test value. And I like the test value of 0. If I put in 0 for x, 0 is less than 9, so that means I want to include 0, and 0 is on the left. So again, I'm going to get the highlighter so we can really see this. So this is our solution set. Okay, everything to the left. Now let's write this in interval notation. Always start with the smallest value. There is no smallest value because this is an arrow, so that means we're going to start with parentheses, negative infinity, comma. Now we're going to go to the largest value, the value furthest to the right, which is 9. And now, do we write a parenthesis or a bracket? Well, this is an open circle, and it can't equal the value, so we're going to use a parenthesis. And that is our interval notation. Let's look at the next one. Okay, construct process. First, x is multiplied by -3. Then we have that product is decreased by 5. And the result is less than or equal to 7. Or equal to 7. Okay, so this was our first step, second step, third step. Okay, let's write our shorthand. We multiplied by -3, then we decreased by 5, and then we had the result is less than or equal to 7. Now let's use our deconstruct process. So we want to start with 7, and instead of decreasing by 5, we're going to increase by 5. Okay, so 7 is increased by 5. Okay. Now we had multiplied by -3, so we're going to divide by -3. So this was a sum, so the sum is divided by -3. And notice I just divided by -3, so I'm going to make a note here. I'm going to make it in red that we are going to change the less than or equal to now goes to a greater than or equal to because we divided by a negative. Okay. And then the last step we have the x, always start with x, is, now instead of doing less than or equal then, I'm going to write greater than or equal to because of this switch. Okay, so x is greater than or equal to the result. Okay, now let's write this out down here. So I'm going to write it on the right so I could save room for the x and the symbol. 7 is increased by 5. The sum is divided by -3, so I take the whole sum, divide by -3, and x is greater than or equal to the result. Okay. Now if we evaluate here, 7 plus 5 is 12. Let's write this on the side. 12 over -3, and we get x is greater than or equal to 12 divided by -3 is -4. Okay. Now let's solve this using the principles of inequality. Okay. Notice first we want to increase by 5, so we could divide by -3 first by the principles of inequality, but it would make fractions, so you don't want to do that. So I'm going to add 5 to both sides, and we have -3x, -5 plus 5 is 0, is less than or equal to 12. Now we're going to divide by -3 on both sides, and whenever you take this step of dividing by a negative, in the very next step, you can't save the reversing the inequality for later. You want to show in the very next step, this is just x, reverse the sign, is greater than or equal to 12 divided by -3 is -4. Okay, so in this case, we divided by -3 at the very end, but if we had to divide by a negative at the beginning, whenever we do the dividing or multiplying by a negative, that's when you reverse this sign because that keeps the inequality statement true. So we got the same result. That's good news. Let's graph it. Our boundary value is -4. So 1, 2, 3, -4. It says greater than or equal to, so I'm going to draw the circle, but I'm going to fill it in. Now we have to decide, is it all the values to the left or all the values to the right? Okay, we'll use TV for test value. Is 0 greater than or equal to -4? And it is, because 0 is greater than negative numbers. So that means we want the right-hand direction. Okay, again, x greater than or equal to -4, that means we're going to go in this direction. Okay, but if you need the practice while you're first learning, it's really good to do a test value. Okay. So this is our solution set. Now to write the interval notation, start with the leftmost value, which in this case is -4. It includes -4, so I use a bracket. The rightmost value, well, this arrow means it continues on forever, so there isn't a rightmost value, so we're going to write infinity, and we always put infinity in a parenthesis. Now let's look at the last one. Okay, let's look at our construction process. So we're going to start with x and decrease by 2. So 1, x is decreased by 2. Then that was a difference, so the difference is divided by 4. And then our next step is that quotient is multiplied by -2. And then we have the result is greater than or equal to 2. Okay, now let's reverse this. We'll put our little notes on the side. Decreased by 2, divided by 4, multiplied by -2, and the result is greater than or equal to 2. So now reversing this, we'll start with 2. 2, instead of multiplied by -2, it's divided by -2. 2 is divided by -2, and now we're going to make our note here. We just divided by a negative, so we're switching from this greater than or equal to less than or equal to. Okay. Now the result is a quotient, so the quotient is, well, it was divided by 4, so we multiply by 4. The quotient is multiplied, running out of room, sorry, by 4. And then that is a product, so the product is increased by 2. And now remember, we start with x and we say x is, now it was greater than or equal to, but we had to switch it, so we're going to write x is less than or equal to the result. Okay, now let's write this out in the solve column. So x is less than or equal to, I'm just going to get that ready, and now I'm going to go through this process. 2 is divided by -2, the quotient is multiplied by 4, and then the product is increased by 2. Okay. So now we can compute this. First, 2 divided by -2 is -1 times 4 plus 2. And then we'd multiply. -1 times 4 is -4 plus 2. And finally, -4 plus 2 is -2. And I'll leave it as an exercise for you to do this using the process of inequality. Let's go right to our graph. So x is less than or equal to -2. Here's -2, our boundary value. I'm going to fill it in because it says less than or equal to. Okay. And now I'm just going to test the value 0. I'm not going to write it out, but notice if we put 0 in here, this is not true. 0 is not less than or equal to -2. So we're going to go in the negative direction. Our interval notation, well, it's -infinity is the leftmost, or the fact that we go further to the left. Okay. And then -2 in a bracket because we can include -2.